So example number 4, solve the differential equation 5x squared y over dx is equals to 6x squared plus y squared, given that when x is equals to 1, y is equals to 5. Now if you look at this problem, the first thing you check if you can use the method of separation of variables. Anytime you have more than 2 terms and x and y are standing on their own, it is impossible to separate the variables. Are you seeing that? So the next thing you check is when they are homogeneous but not linear. Are you seeing? For it to be linear, it must be in the form dy over dx plus by is equals to q, where p and q are functions of x, isn't it? Yes. Meaning y must have a power of 1. But here we have y squared, so it is not linear. Are you seeing that? Yes. So the linear is x. The next one, you check if it is homogeneous, isn't it? If the highest exponent of both variables are the same, then it is homogeneous, isn't it? The highest exponent of y is 2, the highest exponent of x is 2. So that is the same, it means it is homogeneous. So how do we solve an homogeneous ODE? So a first order ODE, if it is homogeneous, we let y to be equals to v. Yes. You differentiate both sides with respect to x, you get dy over dx. This is product rule, isn't it? You take v step, you differentiate x with respect to x, then plus you now take x step, you differentiate v with respect to x, isn't it? So you end up with dy over dx is v plus x dv over dx. Differentiating x with respect to x, you get 1. So you remain with v, dx over dx is 1, plus here, you remain with x dv over dx, isn't it? So where we have y, we are going to put vx, and where we have dy over dx, we are going to put v plus x dv over dx. So start, dy over dx is what? Here, we have 5x squared into dy over dx, which is the same as v plus x dv over dx to be equals to 6x squared plus y squared plus y squared. Where there is y, we put the value of y, which is vx. Where there is dy over dx, we put the value of dy over dx, which is that, isn't it? Are we together? Now here you can see, if you open this bracket vx squared, you are going to get what? V squared x. So you can see x squared is a common factor all through, isn't it? X squared is a common factor all through. So what do? Divide by x. You divide by x squared. By x squared. So what do you remain with there? 5 into v plus, just open that bracket on the spot so that we avoid wasting time. We have this goes with that, x squared goes with x squared goes with x squared, isn't it? So 5 times v you get, then plus 5 times x, 5x dv over to be equals to 6 plus v. There we remain with 6 plus v squared, isn't it? Yes. See, you take 5v the other side of the equation, isn't it? Yes. If you take 5v the other side of the equation, we have 5x dv over dx to be equals to 6 plus v squared plus minus. This was positive. Where the other side is minus? Very good. After you've done that, ladies and gentlemen, what do we have? We can now separate the variables, isn't it? X on their own, v on there. So this one goes the other side, this other one comes this. So what are we going to get? We are going to get dv over, if you rearrange this, so you get v squared minus 5v plus 6, isn't it? Yes, you can see what you are doing here. You are dividing both sides by 6 plus v squared minus 5v. You are dividing both sides by 6 plus v squared minus 5v. If you do that, the other side, then you multiply both sides by dx to take dx the other side, isn't it? So you multiply both sides by dx over x. You multiply both sides by dx over, so that dx goes with dx, x goes with x. So you remain with 5 dv over There is 5, isn't it?
Yeah.
5 dv over that to be the x over. Are you seeing you've separated the variables? See here on the numerator we remain with 5 dv. Then in the numerator we have 6 plus v squared minus 5v. If we rearrange it is v squared minus 5v plus x, isn't it?
Yes.
Yeah, so what do? You introduce integral on both sides. So if you integrate this, what do you have? 5 dv over, what is v squared minus 5v plus 6? See, you can factorize that. A sum of negative 5 and the product of positive 6, that is negative 2 and negative 3. Isn't it?
Yes.
Negative 2 and negative? So it means here you are going to get v minus 2 into v minus, isn't it? Very simple. Those are things you did in algebra. V times v is v squared, negative 3v, negative 2v, then negative times negative plus 6. Algebra on the spot. You are done. Go on the other side. The integral of dx over
X.
Are we together? So what do we do here? We resolve into partial fraction. Now see the power of integration in this topic. You see? The power of integration. So here we have 5 over v minus 2 into v minus 3. So the first one is a linear factor, meaning we are going to have a over the linear factor, isn't it? Then plus the second one is also a linear factor, meaning it is b over that linear factor, isn't it? Having done that, we look for the LCM. The LCM is v minus 2 and v minus 3. So here you have a, v minus 2 goes here how many times? V minus 3 times. Then plus b, v minus 3 goes here how many times? V minus 2 times. Then on this side of the equation we have 5 over v minus 2 into v minus 3. We are resolving into partial fractions. Having done that, the denominators are the same. We compare the numerator. So it means what is in the numerator here, 5, is equals to what? That side, if you collect the coefficients of v, if you take v outside, here we have a times v, meaning a is a coefficient of v. You've collected that, isn't it? Then plus v times b, meaning plus b is a coefficient of v. So you've collected coefficients of v together, isn't it? Then it is plus, you collect the constant term. The first constant term here is what? A times negative 3 is minus 3a. You take it inside the bracket with this sign, isn't it? Then here, you've collected that. You go to the next one, positive b times negative 2, you get minus 2b. You've collected everything. Are we together? Are we together? So we have your v times a, you get your v times a, v times positive b, you get your positive v times b. You've collected the coefficient of v together. Then you've also collected the constant terms together. Take everything with this sign inside the bracket. You can see here we had a times negative 3 is negative 3a. You take it inside, so that addition is what remains outside. Addition cannot affect any sign inside the bracket. Are you seeing that?
Yes.
Good. Having done that, ladies and gentlemen, ladies and gentlemen, sons of Solomon, what do we have here? You compare, isn't it? The coefficient of v on this side of the equation is a plus b. The coefficient of v on the left hand side of the equation is what? It's 0, because we don't have v this side, isn't it? The constant term on the other side of the equation is minus 3a minus 2b. The constant term on this side of the equation is 5. Are we together? Yes. So what is the value of a and b? You can use substitution method. What is a and b? Remember, a is equals to negative b if you take b the other side in the first one, isn't it? Yes. A is negative b, so it means where there is a, you put negative b, isn't it? So what are we going to have? Negative 3 to the value of a, which is negative b, minus 2b is equals to 5. Are we together? Negative 3 times b, see that negative b, see that is positive. Yes. So it is 3b minus 2b is equals to 5, isn't it? So clearly you can see b is 5. 3b minus 2b is b, isn't it? If b is 5, what is a? Negative 5, because a is negative b, isn't it?
Yes.
Are we together?
Yes.
So go back and you substitute your value of A, meaning where there is A, you will put the value of A, which is negative. Where there is B, you will put the value of B, which is 5. Are we together? Good. So we found the value of A and B. Now you are integrating this, meaning this integral is the same as when you introduce integral here. Look at this. When you introduce integrals all through, then you introduce the dv, isn't it? So it means this integral of 5 dv over this is the same as that. Are you seeing?
Yes.
So we are going to have integral of 5 dv over v minus 2. 5 is a constant. I've removed it outside, isn't it? Are we together? Is it 5 or negative 5? It is this one, isn't it? Negative 5, if you remove outside, you remain with dv over v minus 2, isn't it? Then here, if you factorize out 5, you get plus 5 into dv over v minus 3 to be equals to what? Integral of dx over x, meaning where there is this integral, we substitute it with this value, which is the whole of this, and that is what we've done, isn't it?
Yeah.
And it was equals to the integral of dx over
X.
Now, if you integrate dv over v minus 2, what do you get? Chorus ln of v minus 2, meaning you let v minus 2 to be u, isn't it? So if you let v minus 2 to be u, to be v minus 2, that is algebraic substitution. So it means du is supposed to dv. So where there is dv, you put du. So it's like we have du over u, ln of u, isn't it?
Yes.
But our u is v minus?
V minus 2.
Are we together? Good. Integration is the power of differential equations of first order. Then you have plus 5. Go on. Chorus. ln of v minus 3, isn't it? To be equals to dx over x. Meaning the constant must also be ln of, because we have ln all through. So the constant must also be ln of c, because it is ln in each and every term, isn't it? Are we together?
Yes.
But if ln is missing in any of the terms, then the constant is just c. Is that understood?
Yes.
Good. So what do we have here? Ladies and gentlemen, what do we have here? If you're someone who has mastered the concept, if you're someone who has mastered the concept, then what we have here is very simple, isn't it? What we have here is ln of v minus 3 over v minus 2 raised to the power 5. Hello? Remember, this is the same as 5 ln of v minus 3, then negative minus 5 ln of v minus 2. So 5 is the power of logarithm. 5 is the power of logarithm. ln, if you factorize out ln, subtraction goes to division. Same power. Some of these things you just look at them and you see, isn't it?
Yeah.
You don't waste time with them. You look at them and you see. That is exactly what we have, isn't it? Power of observation. Now, having done that, it is equals to what? ln of cx. If you take ln inside, multiplication changes to addition, meaning if you remove ln outside, it is x times c. Loss of logarithms. Are you seeing?
Yeah.
Loss of?
Okay.
So in loss of logarithms, ln cancels with ln. You can ignore ln on both sides of the equation. You can ignore ln on both sides of the equation. Having ignored the Napierian logarithm, substitute back your value of v. Remember, your y was supposed to be x, isn't it? Your y was supposed to be. So that is a clear implication that v is y over. Where there is v, put y over x. So we have y over x minus 3, isn't it? Over y over x minus 2. The whole of this is raised to power 5 to be equals to c. Are we together? Are we together?
Yes.
See, we can simplify this by multiplying both numerator and denominator by x, isn't it? So that we remove this x here in the denominator. Remember this 3 over 1, 2 over 1, isn't it? See, we can simplify. So that when you simplify that, you get y over x times x cancels, we remain with y minus 3x over y minus 2x raised to power 5 to be cx. But we want the value of the arbitrary constant c. You are told x is 1 when y is 5, isn't it? Is that okay? Where there is x you put 1, where there is y you put 5. So what do you end up with? Y is 5 minus 3 times 1, isn't it? Over 5 minus 2 times 1 raised to power 5 is equals to c into 1 because x is 1. You substitute the value of x and y, isn't it? 5 minus 3, 2 over 3, isn't it? Raised to power 5 is equals to c. So what is the value of c? What is the value of c? What is the value of c? 2 raised to power 5 is 32, of course. 3 raised to power 5 is 243. 32 over 243. Very simple, isn't it? So you get C is 32 over 243. Then you substitute the value of C to get the solution. If you substitute the value of C, which is 32 over 243, then you have found the solution of that first order homogeneous ordinary differential equation. Are we together? Very simple and very direct.